All right, so let me do this right quick. Let's,
very first fighter showcase in UFC 4. This fighter showcase is UFC 2.
all right, so today we're going to start talking about functional groups, and hopefully you watched the video. I told you they were long. Each one was about 8 minutes, but the information is there. So what a functional group is, can somebody tell me?
Doesn't it like dictate like the reactivity?
Mm-hmm. So it's an atom, a group of atoms that dictates chemical reactivity. Good. That's really good. Who was that?
Kristen.
Good job. Dictates chemical reactivity. You really only have a few, and the reason I sent the videos is because this is learning functional groups is mostly going to be memorization. We're going to focus more on how they contribute to certain physical properties like melting point, boiling point, freezing point, things like that, how they affect physical and chemical properties. But you really only have a few classes of functional groups. We talked about this in the video, your alkanes, right? That's all carbon, hydrogen, single bonds. Right? Somebody give me another one.
Alkenes.
Alkenes, good. That's where you have a carbon-carbon double bond somewhere present in the molecule. Right? And all these things react differently. So alkanes are highly unreactive unless you got them under certain conditions. Alkenes, you can react. We're going to do reactions of alkenes later on in the semester. Alkenes are really versatile. You can do a lot of different things with those. Right? Somebody give me another one.
Is it alkynes?
Alkynes, good. Right? I didn't put the name here. Alkynes, which are triple bonds or compounds containing carbon-carbon triple bonds, they react in a similar way to alkenes, right? So those are your alkyl, kind of alkyl functional groups. Somebody tell me what this functional group would be if I have an alkyl chain with a halogen on it. This is a halogen, by the way. Right, group 7, fluorine, chlorine, bromine, iodine, astatine, periodic table. What kind of functional group would that be considered?
Is it an aldehyde?
No, it's not an aldehyde. It's an alkyl halide. The alkyl is for the chain, right? That's normally what we call carbon chains. We call them alkyl groups, right? So alkyl is for the carbon chain. And then the halide.
Can you zoom out so we can see all of that? I'm trying to copy it. You going a little bit fast.
Got it? Can you see it now?
That's all of it?
Mm-hmm. I think. You see the word halogen? Oh, you want to see the top part too? My bad. What about now?
Yeah, let me get like a quick picture so that way y'all can move on.
That's cool. I'm recording this too, and I'm gonna save these notes. So I'm gonna post the notes to Blackboard.
Okay, thank you.
Yeah. So alkyl halides, that's another alkyl type functional group. Now, let's talk about some carbonyl functional groups. Somebody tell me one. Somebody already called one out. A carbonyl functional group. Let me draw it, and then you tell me what it is.
Recording this too. I really thought about that.
Right. Keep in mind we've talked about the carbonyl before, right? The C double bond O. It only that's generic. Once you start attaching stuff to this carbon right here, then the functionality changes. Right. So what functional group is this? Well, you have a hydrogen as one of your groups on the carbonyl.
Aldehyde.
Aldehyde, good. Right, this is, and again, there's no way to really learn functional groups other than memorization. But you can group them together. Like we have alkyl functional groups, now we're doing carbonyl functional groups. What about this functional group? If I have a carbon on either side of that,
It's a ketone.
who was that?
Kayla.
Good job. Nice work. It's a ketone, right? What happens when I take the carbonyl and on one side I have, I'm going to talk about that too in a minute.
It'll be an ester.
Ester. Good. Is that you again?
Yes, sir.
You've been rocking and rolling this weekend, huh? That's good. That's what it's going to take. It's an ester. The ester, look at the difference, right? The ester has a what we call a alkoxy group. The al for the carbon, the alk for the carbon, the oxy for the oxygen. So it's alkoxy, right? Ketone has carbon on either side of the carbonyl, right? So, and I promise you, being able to identify these functional groups, when we get to later parts of the chapter or the course, and when we get to part 2, those functional groups are gonna make you or break you, because all your reactions happen on different functional groups. All right. So I promise you, make some flashcards, do whatever you got to do to build your functional group vocabulary. Because when we get to the second part, those of you that get to the second part, I'm not going to go back and explain what an ester is. I'm just going to put it up, right? Or a ketone or aldehyde. That's why you always want to build your foundation, right? You don't want to have a weak foundation or try to finesse through. Because if you finesse through and get to the second part, you're going to be up the creek. So you can work on the
No. I put other ones in there.
All right. So we got the aldehyde, ketone, esters. All right. And then let's do another carbonyl. Notice the carbonyl is common to all of these. The C double bond O is common to all of these, right? And then let me add another one in. Let's do a so here's my carbonyl, and then this is OCH3, and then CH3, right? This is what we call a carbonate, right? And then you have right? Notice the carbonyl right here. The difference between this and the ester is that now you have a nitrogen group attached out here. And somebody tell me what that is.
Is it a mod or a amine?
Okay, great. It's one of them, right? Because of the nitrogen.
I think it's a mod because a mod has that group, right? I don't think amine does.
It's the amide. We call it the amide or amide.
Oh, sorry.
No, it's fine. We'll take that too, because at least you gave me something. I'm taking it. It's called an amide, and it's similar to an ester, except for that oxygen is replaced by nitrogen, right? The amine doesn't have a carbonyl, right? So this will be what we call an amine. There's no carbonyl on the adjacent carbon right here. Are you following?
Yes, sir.
So the way I kind of help students remember that is the amine is out of jail and the amide is in jail, right? What do you mean, Dr. Russell? The amine has no CO, right? But the amide does. Y'all know what a CO is, right?
Yeah.
Okay, good. Maybe it'll make sense in the by and by, maybe by lunchtime. But the amine it has a nitrogen, but it doesn't have a carbonyl adjacent to it, right? So it's just a free nitrogen. And then speaking of amines, how many different types of amines can you have? Somebody remember that?
Is it 3?
You can have a primary amine, is that right?
Yeah,
You have
secondary.
nitrogen, I'm just gonna do that, connected to one carbon. You can have a secondary amine, where you have nitrogen connected to 2 carbons. I gotta zoom in on that. How the heck is it raining and sunny at the same time? Right, so here's as a secondary, and then you have a tertiary amine, where you have your nitrogen connected to 3 carbons. Right, so this is primary. Whenever you see that 1 degree, that's called a primary. And then this is secondary. And then this is tertiary.
Do they use like that degree sign to describe other things?
Yeah. I'm glad you asked that, because the same way you can have primary amines, you can have primary, secondary, and tertiary carbons too. That's a great place to introduce this. So let me actually, I'm gonna draw a chain out. So this carbon right here, that's what we're gonna highlight. This carbon will be primary. See, because it's only bonded to one other carbon right here. Right, and then this carbon right here will be secondary. Right, can you see that? Because it's got a carbon bond here, and it's got a carbon bonded to it here. And then this carbon here will be tertiary. Right, because it's got 3 carbons bonded to it. It's got a carbon bonded to it here, 1 here, and 1 here, so it's tertiary. Great question. I'm glad you asked that. So primary, secondary, and tertiary is really, it really points to the number of groups that are attached to a particular carbon or another atom like nitrogen or something like that. All right, any other questions? Right, so what type of functional group is this?
Is that an alcohol?
It's an alcohol. And you know that because of the OH group. Alcohols can also be primary, secondary, or tertiary. This, what type of alcohol would this be? Somebody tell me. It's based on the carbon where the OH group is. Tell me what you think.
What was the question again?
What type of alcohol is it? Is it a primary? Because you can have primary, secondary, or tertiary alcohols also. Just like you can have primary, secondary, tertiary amines. Right? So this is a secondary alcohol. Somebody tell me why.
Because it's connected to 2 carbons.
Yeah. The OH is on a secondary carbon, right? This carbon that's in pink has 2 carbons attached to it. So it's secondary. You can also have tertiary alcohols like this one, right? Can you see that? So the carbon where the alcohol is going to be the primary, secondary, or tertiary part. Let me fix that. That looks sloppy. All right. So this would be a tertiary alcohol. And then obviously this would be a primary alcohol. Is that okay so far?
Yes, sir.
All right. What about this functional group? And then we're gonna jump on this handout.
Ether.
Good. It's an ether.
Ether, I mean.
That's okay. I appreciate. Who was that?
Kristen.
All right. Well, you trying to get some lunch money today? Just going in. All right. It's an ether. What's the characteristic? You have an oxygen atom here, and on either side of that oxygen atom, you have sigma bonds to carbon, right? That's the key. The oxygen with a sigma bond to carbon on each side. That's what an ether is.
So it can't be drawn any other way.
How would you draw it?
Well, I've seen it in the form
Of a ring?
Well, it was kind of like the carbon, the skeletal form. Then it had like the line sticking out, and it was an O connected to CH3.
Oh, sure. You mean like if I drew it like this, like that?
Yeah, I guess you can draw it like that.
There's no limit on what those carbon groups can be.
Okay. Thank you.
Mm-hmm. All right, so let's jump over here to the same handout we've been working on. Remember, I told you you're gonna have to probably end up turning in more than once because of the other part that's on here that we're gonna discuss. All right, so let's jump right up in here and name these functional groups. So what is this functional group right here? No, speak out at once now. Might be kind of loud.
Is it an acid?
I didn't do that one, but we're gonna do it. Yeah, it's not an acid. Look at
alcohol. Is it an alcohol?
It's alcohol, right? How do you know it's alcohol? It's just an OH group, right? That's connected to something else. It's not connected to a carbonyl or any other type of functional group. It's just connected to a carbon. Is that okay? What about this functional group right here? We're going to call it by a generic term. We're going to call it an aromatic. This phone been buzzing all morning. So we'll call that an aromatic. What about here? So do you see the carbonyl here?
Yeah.
What's connected to it?
Nitrogen.
There's a nitrogen connected to it. So what functional group is that with a carbonyl that has a nitrogen group attached to it?
Amide. What? Hold on. How do you pronounce it again?
Amide.
Amide.
Mm-hmm. You're right though. I ain't even tripping about that. It's an amide. Y'all following that?
Yeah.
All right, let's do the next one. That's just a warm up because everybody's quiet, scared. Oh no, it's different problems. What is that? I need some Jeopardy music.
Aromatic.
It's an aromatic. Thank you for not being scared. It's an aromatic. Even if you're wrong, it's okay. That's why we're doing this. You mess up now, not on the test. It's an aromatic. What about this group down here? What is that?
An ether.
Good. Who was that?
Caleb.
Good. Just Keep it coming. That's the ether. And then this group over here.
Amide?
Can't speak up.
How do you say it again? Amide?
Yeah,
Amide? Amide?
the A is short. So that's the amide. Good. Really, that's great. What about this group? I didn't put it on that first sheet that I was working on when I was just writing out the notes. But what about this group right here? I heard somebody say it earlier.
Acid?
It's an acid.
Yeah,
Carboxylic. It's a carboxylic acid. What's the difference in the acid and the ester?
Would it be that double bond?
Mm-mm.
The
No.
carbon in the acid, the carbon is bonded to the what's this called? Hydroxy? Hydro.
In the acid, you have a hydroxy group attached to the carbonyl. That's right. And in an ester,
The carbon is bonded to the oxygen.
it would be a alkoxy group, like something like OCH3 or something like that. That's the difference.
Okay.
Right? Or if you just look down here at this example, is that an ester?
Yes.
It is. You see the C double bond O right here, and then the O carbon bond right here.
So the difference is the O and the OH.
Mm-hmm. What's on the O? That's the difference. If it's an OH, it's an acid. If it's O carbon, it's an ester.
Wait, so what's the difference between that and the alcohol?
Oh, the alcohol would just be the OH solo. It wouldn't have a carbonyl with it. Right. So the alcohol, let me see if I can do this. The alcohol would be, now if the carbonyl was gone, you feel me?
Yeah.
That would be an alcohol.
Oh, okay.
You see the difference?
Yeah, because it's just bonded to that carbon.
Yeah, it's just a CO single bond, and the O group, the oxygen is a hydroxyl group. Do you see the difference in that?
Yeah.
Mm-hmm. But the minute I put that carbonyl there, it becomes a carboxylic acid.
Okay.
Right, and then this down here is an ester. Right, so you need to make you some flashcards for these functional groups. I promise you, they'll save your life, because you don't want to be thinking about it when you're on the exam. This is the cake part of the exam. Compared to the other stuff that we're gonna be doing on the next test, this is the easy part. Matter of fact, let me do this. Let me see if we can make the stakes higher. That way more people will talk. Let's do this. I'm actually going to go back into that 1A. And there's an extra credit assignment here somewhere. Yeah. All right. Let's look at this group, this molecule. This is Taxol. This is actually a anti-cancer drug. If you have a relative or anybody in your family who's had breast cancer, this is one of the drugs that they give to shrink those tumors down, right? My wife actually took this. This was the first thing she took when she was taking chemotherapy. My late wife. First drug they gave her was Taxol. It's a very, very powerful anti-cancer drug. The only problem is it comes from this tree. It's called a Pacific yew tree. And it takes 100 years for one of those trees to grow, and you can scrape all the bark off and you only get a few milligrams, right? So someone had to come up with a way to make this. So Taxol has actually been, the synthesis was patented by a chemist down at Florida State. I want to say his name is Robert Hoffman or something like that. Anyway, he sold the synthesis to Bayer, and he gets royalties every time this stuff is made or sold. He sold the synthesis for like $2.5 million, and then he gets royalties off of the sales. Anyway, let's see if we can go through here real quick and look at some of these functional groups, and you tell me what they are. And yeah, we're gonna make it worth something. All right, what about, okay, let me go ahead and put this out there. When you see a pH, that's an abbreviation for that aromatic ring. Do y'all remember what that ring looks like? Should I draw it out? It's gonna be crappy now, I'm using my mouse pad. So it's a 6-member ring like that, and it's got alternating double bonds on the inside of it. So anytime you see pH, that's what that is. It's an abbreviation. Come on. It's an abbreviation for this benzene ring. All right? Or aromatic ring. So don't panic about that. So how many pHs are in here? 1, 2, is that right?
Yes, sir.
3. Okay? So you got 3 aromatics. All right, I'm gonna put some lunch on the line in a second. What functional group is this?
Amide.
Look at it. Who is that?
Taina.
Oh, nice work. It seems like that's y'all's favorite. Y'all can pick those out anywhere. Y'all can pick those out. It's an amide, an Arab, something. It's an A something. But that's good. That's right. That's an amide. Good. What about here?
Alcohol.
God, dog. Yes, that's great. It's alcohol, and so is what? This and this. Yes. How do I know it's not a carboxylic acid?
Because there's no double bond.
It's not connected to a carbonyl. A carboxylic acid is going to look like this. It's going to have a carbonyl. Hold up. Oh, I picked the wrong thing. My bad. It's going to have a carbonyl, right? I hate using this mouse pad. It's going to have a carbonyl connected to it. Then it'll have an OH group out here. If you don't see a carbonyl adjacent to the OH group, it's not an acid, it's alcohol. That's great. What about here?
Ester.
And ester.
Ester. Good. Good. Y'all are picking this up quick. I'm glad. All right. These are also esters. Let me show you the OAC. You see those groups out there? Let me show you what that AC looks like. So AC is an abbreviation for acetate. Let me see if I can write this out without it looking like a second grader. So AC is, well, hold up, you know what? I got a better trick than that. I won't have to worry about handwriting. So AC is short for acetate. What an acetate is, it's a type of ester. Right? So it's O, it looks like this. Excuse me. So it's O, like this, and that's connected to a carbonyl, which is connected to a methyl group. Right? So that OAC looks like that. So that's what's connected right here. So it's O, C double bond, OCH3, right? So all of those are esters. That's awesome. I'm glad y'all picking this up. This is great. What about, do you see another ester that I'm not picking up?
Is it the one near the
That
P?
one that your mouse is by?
Right here?
Yeah.
Absolutely. Right, that's also ester. What about here? What is this?
Alkane.
Alkene. Who was that?
Kristen.
Good. It's an alkene. That's exactly right. What about here?
A ketone.
Ketone. Very good. Very, very good. And let's see. There's only one left, and that's this. What is that?
An ether.
Ether. Good.
Ether. Gosh, I'm gonna get it right one day.
All right. I know what you meant though. That's what matters. It's the thought that counts. So it's an ether. It's a type of ether. So ethers can be, that's a great place to introduce this to. An ether can be cyclic or it can be acyclic. When you hear that term, cyclic, all that means is that it's in a ring. Why am I wasting time trying to draw that when I can type it? I can put it right on over here. So cyclic or acyclic, right? One really common cyclic ether, I am going to draw that, is what we call an epoxide, right? So that's a 3-member ring. It's a 3-member ether. It's got an oxygen here, and it's got another bond, a carbon here. So this is an example of a cyclic ether. And the proper name for it is what we call an epoxide. Right, that's a very common ether. We're going to actually look at how to make those later on. Well, we picked all the functional groups out in here, which is great. So if you haven't done this as extra credit, you can do it now, and you just got it for free. Well, you ain't get it free because a lot of people chimed in, but you can get the points. That was good, by the way, for everybody who chimed in. Thank you. All right.
Excuse me, Dr. Russell. I have a question.
Go ahead.
I keep hearing ester and ether. What's the difference?
So ether is, let me just draw it out right quick. So an ether looks like this. It's got I'm just gonna draw the simplest one I can think of. So I got a CH3 on each side, or a carbon group, some carbon containing group on each side, right? That's an ether. And ester is actually a carbonyl functional group. So we got carbonyl here, and then I'm just gonna do OCH3. Right? That's the difference. Ether does not have a carbonyl. It's just sigma bond from oxygen to carbon on each side of oxygen. And then, of course, let me put the lone pairs in. Right? But an ester is totally different because it actually has a carbonyl as a part of the functional group.
Okay, thank you.
Good question. I promise y'all, if you make some flashcards, this will be cake. When you see it again, it's going to be cake. All right, let's go back to the handout real quick. Let me see. Matter of fact, I'm going to go. Let me do this right quick. Let's see. We actually looked at some functional groups up here. But let's go back to some of these examples and see if we can pick out the functional groups. And then we're gonna move on to something else. What functional group is this?
Is it an aldehyde?
Yes, it's the aldehyde. Why do you say that?
Because it's connected to a carbon and a H.
That hydrogen gives it away. A hydrogen that's on that carbonyl carbon tells you it's an aldehyde. What about here? Specifically here. Uh-oh, I'm trying to do that. Specifically there, what is that functional group?
Is it alcohol?
It's alcohol. Is it primary or is it secondary or tertiary? How many carbons does the carbon where the alcohol is have attached to it? That's how you answer that question.
Is it 3?
It's got a hydrogen on this side. Is that right?
Yeah.
And it has a carbon on this side. Is that right?
Yeah.
I have to put in another carbon. That might be a typo. And then it's got a carbon there. So what is it? Primary or secondary? It's got 2 carbons attached to it, right?
Yeah. So it'll be secondary.
So secondary. It will be secondary. Oh gosh, let me turn this phone off.
Wait, so we're trying to figure out if it's primary or secondary.
You look at the carbon where the OH group is and see how many carbons are attached to it.
Oh, okay.
All right, let's go up to, what about here? What functional group is that?
Ketone.
It's a ketone. What do we call that? Carbon-carbon double bond.
Alkene.
It's an alkene. All right, good. Let me see. Already did that. What about here? This part right here. What functional group is that? Keep in mind, there's no carbonyl anywhere.
And
It's an amine.
amine.
All right. What type? Is it primary? Is it secondary? Is it tertiary? I'm gonna give you a way to remember that. If there's only one hydrogen attached, then it's secondary. If there's no hydrogens, it's tertiary. If there's 2 hydrogens, it's primary.
So when we're looking for like primary, secondary, and tertiary, we're counting the carbons around it?
Yes.
Okay, great.
But the more as you increase the number of carbons, you decrease the number of hydrogens. So, but this one has 2 carbons right here. Is that right? On either side. So this will be a secondary amine. Is that okay?
Yeah.
Yes, sir.
So this is just going to take you doing some reps with these functional groups. If you look in the syllabus, you're going to see a bunch of different highlighted problems from the chapter. That's what I would practice with, right? Or what you could do is, matter of fact, let me do one more thing. Let me see what we're working with. How many of you have heard of this compound right here, Remdesivir? Anybody?
No, sir.
No? Let me show you what it is. So this is Remdesivir. I want to blow that up. It's actually a drug that's been developed to fight COVID. Because it looks like ATP, which is what COVID uses to fuel its replication. All right, so this is Remdesivir. So you take this And let me show you what ATP looks like so you'll see what I'm talking about. Let's see, what can I close? It'll come up at some point. Actually, you know what? Let me do this because I got this in a PowerPoint with both of them. But we're gonna pick the functional groups out in a second. Where is it? Here. But these functional groups are, it's a must to understand them because they actually control how everything works. Carbonyls react a certain way. If it's a ketone, an aldehyde, ester, amide, they all have different reactivity patterns and they all react with different things. So it's really important to understand the functional groups and to have them memorized. So when you see them, it's less of, here we go. It's less of a function of what is it and more a function of what it does. Can y'all see that, my screen?
Yes.
Yes, sir.
All right, here we go. So let me scroll down here. So this is, we actually did a little study this summer. I had a high school student I was working with. And we wanted to compare Remdesivir and ATP. I think there should be an oxygen here. All right, so if you look at the two, so this is ATP. This is what the virus actually uses to replicate. Part of what it uses to fuel its replication, right? And so if you look at the ATP and look at Remdesivir, you notice that all of this stuff here, the PO, the phosphorus part, and all the other stuff is identical except for this one group right here, right? If you look at that, you got the two, well, I'm not gonna tell you what they are because I want you to tell me, but you have these two groups here that are identical. The ring is identical. The OP bond is identical. And then this quinine ring over here is also identical to ATP. So the way this works, the way Remdesivir works, is the virus mistakes it for ATP, but then when it starts to metabolize it, this group right here gets taken off, and all the other groups get taken off, and then basically it slows down replication or stops it completely. Because it's basically like a Trojan horse. It looks just like ATP to the virus, but when it takes it, it basically destroys the cells. All right, so let's go through here and pick the functional groups out. Let's see if we can do that. Let me get my get this up here so I can annotate. All right, what is this functional group right here?
An amine.
Yeah, it's an amine, right?
Dang.
You're gonna get it when you eat lunch today. You're gonna it come to you. That's an amine. What about here?
Aromatic.
Aromatic.
Aromatic, good. What about here? What would you call that? All carbon single bonds.
Alkane.
It's an alkane, or when it's attached to something, we call it an alkyl group.
Alkyl group.
Mm-hmm. Good. I'm gonna write that down here. So it's an alkyl group. What about here?
Ester.
Good. It's an ester. That's exactly right. And here?
Alcohol.
Alcohol. Good. What about here? Have you ever seen that before?
Yes, I want to say it was on one of those sheets that we did in class, but I didn't know how to do it.
Yeah, it was, but we didn't name it. We didn't know what it was at the time. So let me make this make it clear that this is a, I need to erase that circle, that this is a carbon right here. Now, don't miss that. That's a carbon on that side. Are you following? We call it a, if we for functional group purposes, we call it a nitrile. Right, it's a carbon with a triple bond to nitrogen. We call it a nitrile. Right? But if it's just by itself, we call it, because different things can be attached to that carbon. But if it's just the CH, we call it cyanide. Everybody's heard of that cyanide before, right?
Yes, sir.
You didn't hear it from me, but the best way to poison somebody, is this recording? Never mind, it's recording. The best way to poison somebody is by using cyanide, because you can't smell it. Can't smell it and you can't taste it. So by the time you've ingested it, it's too late. You're already dead. You know how it works? What's that? Who trying to get some details?
How did you say you know? So how do you say it again? Cyanide. How do you?
It's a C. So if this on this carbon that's just an H, right? We call it a cyanide.
Okay.
But if it's nothing there, if it's just attached to some other like random group, like it is connected to carbon, we call it a nitrile. So the names are interchangeable, but it's a very potent poison. It's a gas for one, and then if it's not connected to something, if it's just floating free, it's a gas. And the way have you ever heard about cyanide poisoning? How it works?
I've heard about it, but not about how it works.
What's the hybridization state of that carbon?
SP.
Who is that?
Taina.
Good. You get lunch today. It's SP hybridized. What's the geometry if it's SP hybridized?
Linear.
Speak up.
Linear.
Linear. So cyanide and oxygen to the body look just alike. This is what oxygen looks like. It's also linear, right? So to the body, cyanide and oxygen, if this is a real cyanide molecule, the carbon has 2 electrons on it like that, it looks just like oxygen. So when it's ingested, the cyanide replaces oxygen in your hemoglobin. So you basically suffocate, right? Because you can't get enough oxygen because the cyanide is replacing oxygen on hemoglobin. So that's why it's so poisonous. It's got a little smell to it. It kind of smells like almonds, but you smell it for too long, you ain't gonna be smelling nothing else after that. So this, let me introduce you to the other 2 functional groups, because I know you're thinking about them. So this functional group right here is, I'm gonna type that because that's gonna be a lot to write. It's what we call a phosphor amide, right? Phosphor for the phosphorus, amide for the nitrogen that's attached to it. And then the other functional group down here that I know looks like real crazy to you, it's a type of aromatic, but it has a name. We call it a triazole. So it's called a triazole. But again, all these functional groups, in order for remdesivir to work, the functional groups have to be there, and the virus has to be able to recognize them in order to bind it up, take it up. You try to use it to fuel replication, and then eventually die. My personal thought is that this cyanide somehow during the metabolism, that cyanide comes off, and that's what kills the virus. but I don't know that for certain. That's just my thought. But it does stop replication. It's also been used. Remdesivir has also been used for Ebola too, tested for Ebola. But that's what they're giving a lot of patients now. I think it's a 7-day course of that, but not hydroxychloroquine. All right. Any questions so far? I think the functional group stuff is pretty straightforward. You just need to practice with that. I'm going to send you some videos after this dealing with intermolecular forces and solubility. And that's what we're going to do on Wednesday. Of course, we'll hit functional groups. Anytime we see functional groups, I'm going to bring that up because that's like a work in progress. But every biological molecule, any molecule with some biological activity has some type of functional groups on it that give it that biological activity and tell it how to interact with the things around it. That's the beauty of functional groups. Yep.
I got a question, but this isn't about functional groups.
Okay.
So you said they're using this on like patients or whatever that have COVID.
Yeah.
So who gets to decide like, okay, you can try this?
Well, remdesivir has already been studied, right? It's FDA approved for that family of viruses and those type of viruses. It's already been studied. So it's basically, you got really two ways you can do it. The safe way is to go through the FDA and go through clinical trials and test it on human beings, but you can't test it on humans until it's like a process. You test it in a test tube, and then you move to phase 2 where you might test it in animals. And then in phase 3, that's when you test it in humans. So all that's FDA regulated. The way you get around it is to not sell it as a drug, but as a supplement. None of the majority of your supplements that are on the market are not FDA approved. So they haven't really been studied as rigorously as something that would require FDA approval. But this is actually a drug that you can, I think Gilead is the company that sells it, that makes it and sells it. But that's a real drug that's been tested on a bunch of different viruses. But the FDA is the regulatory agency that says what's safe and what's not safe. So what was this thing they were coming? Did y'all see this? Let me share my screen or do a new share. Did y'all see this? Oh yeah, right here. Did y'all see this drug, Oleandra, that they were trying to push recently? Did y'all hear about that?
No.
No? I'm gonna show it to you. Matter of fact, that's a great extra credit assignment right there. If you can take Oleandra and find all the functional groups that you can. Let me pull it up. It's kind of like it's in the cholesterol family. Well, let me pull it up because I remember when, of course, if you have a family member that is dealing with cancer, like I did with my wife, I was trying to find, as a chemist, you always looking. So Oleandra is a compound here. It also has some anti-cancer properties too, but it's really poisonous. And so the plant is, can y'all see the plant over here? Comes in different colors, pink oleander, white oleander, but it's really, really, the oleandrin itself is highly toxic. So you have to, if you do want to get it and extract it from the plant, you got to be really judicious about what you're doing, number one. And number two, when you extract it, the concentration that if you choose to ingest it, because some people do make tea from it, but I wouldn't. I was afraid that if I did that, it may have killed my wife. So I didn't want to do it. But the oleandrin, they were just trying to pass this off as a treatment for COVID. But the way they did it to skirt the FDA, they were trying to sell it off as a supplement and not as a drug. So anytime you want to get around the FDA, that's what you do. You just sell it as a supplement. But this is a great extra credit assignment. If you can Google oleandrin and find all the functional groups, I'll accept that. I'm gonna put a link in the assignments tab for that, so you can turn it in for extra credit. There's a story about Oleandra. I think it was either some Navy sailors or soldiers that were stationed in Hawaii, and they had a cookout. And you know how sometimes you make your own little rotisserie. But they used the oleander stalks for their hot dogs. So they roasted their hot dogs on that, and all of them died because the oleandrin that was in the stalk, obviously when they heated it up, it got absorbed into the meat that they were getting ready to eat. So they all died. Highly toxic compound. I wouldn't recommend it.
We just email it to you when we do it.
Now I'm gonna put a link in the assignments folder on Blackboard in 1A, in module 1A. Actually, let me do that right now. You can knock it right on out. Any questions about these functional groups? So we're gonna push forward. We're gonna push forward with some other concepts, but you'll never get away from these functional groups. So my suggestion is to make you some flashcards. I'm gonna make this worth 10 bonus points. That should be some good motivation right there. All right. Any questions about anything?
No.
No. Can you see how this is actually has some application? It's not just something on paper. It's real life. Organic is real life, but I don't want to get on a soapbox because we're 5 minutes over.
Yeah, it's interesting.
Mm-hmm. It makes you appreciate like the stuff you can't see, you know. Because then if you take an Advil or Tylenol or an antibiotic, you just taking it. But if you really understood what you were taking, then you can understand how it interacts in the body or how it interacts against bacteria or virus or something like that. It's all connected to the functional groups. All right. No questions?
No, sir.
All right, cool. I'll see y'all on Wednesday. I'm about to send y'all some videos to watch for Wednesday. And I'm gonna post notes from today on Blackboard. And I'm also going to upload this video to YouTube. So I appreciate y'all's feedback and engagement. We keep it like that. That'll make the semester go by a whole lot faster. And T, I haven't forgot you. I'm about to send you your lunch money now.
Bet. Thank you.
Mm-hmm. All right. Y'all have a good day, and I'll see you on Wednesday.
Bye.
All right.
Thank you. Bye.
All right.